Hey everyone, welcome to the Biomed and Chemical Engineering Committee activity. We are going to be talking today about allergies and drug delivery. So you might be wondering what it is that chemical and biomedical engineers actually do. Chemical engineers work primarily to safely produce large amounts of fuel, drugs, food, and more. Biomedical engineers work to produce medical devices such as artificial organs, replacements for body parts, and machines that can help diagnose medical problems like an X-ray. So I'm sure you guys have some favorite snacks that you like, such as maybe goldfish or Oreos or chips or something like that. And all of those are processed foods, which means that a chemical engineer probably designed the facilities where they are made. And some of you guys have probably maybe broken a bone before and have had to have an X-ray or have had some other scan to diagnose your medical problem. So did you know that in 1993, a group of biomedical engineers from Scotland developed the first fully functional bionic arm that worked as if it was natural? It was a complete prosthetic arm, and these engineers designed it, and it worked basically as if it was the real thing. Did you know that biomedical engineers have developed special types of bacteria to use in vaccines like flu shots and more? So I'm sure you guys have heard of coronavirus at this point, since we have been in a pandemic for a while now. But biomedical engineers can actually develop bacteria that goes in vaccines, like what you get for the flu and what maybe you're getting or eventually will get for coronavirus. Did you know that chemical engineers likely design the factories where some of your favorite snacks are produced? So like I said in the last slide, chemical engineers probably design the facilities where things like goldfish, potato chips, Oreos, and stuff like that are produced. So in this case, don't worry, we aren't talking about drugs that you should most definitely say no to. In this case, drug delivery means medicine delivery. And as biomedical and chemical engineers, it's important for us to know the different ways that drugs are delivered inside of the body. So what is drug delivery? Have you ever been sick and have to take a medicine to make you feel better? Was that medicine a liquid or a pill? There are lots of ways that medicine can be delivered to the body and many reasons for the different methods. Maybe you have allergies and you need to take allergy pills, or maybe you have a fever and you have to take a liquid medicine. Each type of medicine has a different purpose. So what are some methods of drug delivery? Do you guys have any guesses? We know what drug delivery is, but what are some ways that we can deliver medicine to the body? So there's pills, liquids, an IV, injections, creams or ointments, and respiratory, which means that you breathe it in. So here we have Neosporin, which I'm sure you guys have maybe fallen and scraped a knee, and you've had Neosporin or some other ointment put on where you've cut yourself open, and then you have a Band-Aid put on it. Then there's also EpiPens, which maybe some of you guys have allergies, and you have to inject yourself with an EpiPen if you go into anaphylactic shock. And then of course we have an inhaler, which maybe some of you guys have asthma or have had some sort of sickness with your lungs like bronchitis where you've had to use an inhaler in order to help. So why do we want different methods of drug delivery? We know some of the ways that we can deliver medicine to the body, but why is it important for these engineers, both biomedical and chemical, to understand drug delivery? So different medical problems need different medical solutions. That's one of the biggest reasons. Some medicines need to work fast, like an EpiPen, and others need to last a long time, like allergy medicine. An EpiPen, you obviously want to work fast so that you can maintain your breathing and stuff like that if you have an allergic reaction, but some things need to last a long time, like an allergy medicine where you take it once a day and it helps your symptoms subside for different allergies like to pollen and the weather outside. So some methods also just work better than others for different problems. How can we make drug delivery longer? For our experiment today, we're talking about allergy medicine, which we want to last all day long. So how do we make that happen? Engineers can actually slow the release of medicine inside of the stomach using different methods. You can use capsules instead of smaller pills. You could use solid tablets, liquid medicines, and the slower the medicine is released, the longer it will last. And here's a cool little GIF of a capsule of medicine being released. So our experiment today is going to be making our own drug delivery system. We are going to be using Skittles and Sprite to simulate the drug and the environment. So the Skittle is going to simulate the medicine, and the Sprite is going to be the environment. So your goal today is to create a coating for your Skittle to make it last longer in the Sprite. You can make a clay-like dough out of the materials, or you can coat them in the materials just by themselves. It's really up to you. Start by brainstorming and then move on to the experiment. So here are some steps to follow. First, you're going to want to place a plain Skittle in the Sprite as a comparison and watch what happens. You want to see if the colored coating around the Skittle dissolves quickly or slowly. And make sure to notice if the hard coating of the Skittle completely disappears or not. Second, you're going to want to think of different ways to create a coating for the Skittle. The goal here is to make the Skittle dissolve a little slower than the first one that we did. So using the supplies, you can create a little dough or maybe a paste that can protect the Skittle, which we'll show you some different ideas and examples for coating the Skittle here in the video of the activity in just a second. Make sure you want to notice here, is there a difference in the coating if you mix the ingredients in a different order? So say I coat something in flour and then I coat it in cornstarch versus if I coat it in cornstarch first and then in flour. So once you have your coating, you want to put your new drug in the Sprite and see if it lasts longer or shorter than the control. So after you look at these different coatings here, make sure to pay attention to what you could do differently to make a different coating, and ask yourself, what different applications could these coatings have for an actual medicine?
All right, so here we go. I'm pouring the Sprite here into a clear cup to make sure that I can see the reaction. And then I am just going to take one Skittle, not coated in anything, and drop it in. So here, we'll zoom in for you guys. You can see that the Skittles coating is dissolving pretty quickly because the bubbles are going at a fast rate. Eventually, you will see that the orange dissolves completely and the Skittle just turns white because it has no orange coloring on the outside of it anymore. And the Sprite actually begins to turn orange. So here we have our timer started, and we're just going to let it keep going until it turns white. So because the Skittle sits on the bottom of the cup, you're going to want to flip it over, which I am doing right here, just to get that last little spot of the coating completely dissolved. So now that you flip the Skittle over, you just need to let that last little bit of color completely dissolve, and then make sure that you record the time that it took to completely dissolve all of the colored coating, and you are good to move on to the next Skittles using the materials that we have listed for different ways to slow the dissolving process. And that's it. So I'm just going to take it out. And then here is our final time whenever we did it. So your alls might be somewhere close to there. Okay, so moving on to using our different materials. I'm starting here by coating the Skittle in flour alone. And then I am placing it on this paper towel here with just flour labeled so that you guys can see the different ones that we make. So then I'm going to put some cornstarch into a bowl to do the same thing, repeat the same process by just dipping the Skittle into the cornstarch by itself and then placing it on that paper towel for you guys to see everything labeled. So the next one that I'm doing is sugar by itself. This is just regular granulated sugar. So I'm putting some of that into the bowl, and then I'm going to coat the Skittle in that too. So this one was kind of stubborn and doesn't stick super well, but still went ahead and used it. It's worth trying. So next I'm just going to take some flour, put it on this little clear plate that I have, and then I'm going to add some oil to it to kind of make a runny paste. Here I'm just mixing it up. So now I'm just grabbing another Skittle and then coating it in this little mixture that I made. So now I'm doing that same thing, but instead of flour, I am using cornstarch. I just put some cornstarch on the separate plate, and then I'm just going to add a little bit of oil to it, and then mix it up and coat the Skittle. And since the cornstarch has a little bit of a different consistency than the flour, I used a lot less oil this time. So like the flour and oil mixture, this one is also more paste-like. And then I dipped the Skittle in the cornstarch first just to help it stick a little bit better. And now I am coating it in the cornstarch and oil mixture. So the next one that we're going to do is just a freestyle is what we called it. And this one you can basically just mix anything that you want. So I just did a combination of all of the different ingredients that we have. As you can see here, I did some scoops of flour, and then I added just a little bit of sugar, and then finally some cornstarch. I'm going to add some oil here in a second just to mix it all up. So now I'm just adding the oil, and then I'm going to mix that all together to bind it together, and then I'll put it in the Skittle. Now I'm just adding a little bit of extra flour to thicken it up a little bit more and make it a little easier to go on the Skittle. So now you can see that it's really just a dough kind of paste situation, which is going to make for a pretty thick coating around the Skittle. So now I'm adding the Skittle and I'm just going to cover it. So spoon works a little bit, but it's easier to just grab it with my fingers. Then I'm just going to roll it into a ball and place it on the other paper towel. There you go. There's our freestyle. So for this one, we also wanted to demonstrate that you could just dip it alone in the different ingredients. So here I just dipped it in flour and then I dipped it in oil. And then I put it back in the flour. So for this whole section, I'm really just showing you different ways to dip your Skittles into the different ingredients. These are just examples. You don't have to follow all of these exactly or do all of these at all. In our video, you'll see later, I don't test all of these in the Sprite. I just pick a couple. But this whole section, I really just wanted to demonstrate that you could do multiple dips into the different ingredients. You could just do one ingredient or you could use two. Really anything. You can just get creative and just pretty much do whatever you want. So for this green Skittle, you can see that I did multiple layers, went back and forth between the oil, the flour, the cornstarch, and the sugar. And now it is completely layered up. So I'm going to do this purple Skittle in just oil, since we have just sugar and just cornstarch and just flour. And then here are all of our combinations. So now I'm taking the Skittle that's covered only in flour and I'm dropping it in the same glass of Sprite that we used before, just to demonstrate that the one that's covered in just flour will take longer than the one that we put in originally, the orange Skittle that we did first. It didn't have anything on it at all. So as you can see here with this purple Skittle compared to the orange Skittle that we did first, you can already see that the bubbles are coming off of it more slowly than the orange Skittle did. So therefore, this purple coating is going to take a little more time to completely dissolve off than the orange. So if we think back to the orange Skittle that we did first, it obviously dissolved pretty quickly and the orange coating was gone pretty fast. So that would simulate a type of medicine that would need to be working pretty quickly, such as an EpiPen. But in this case, the purple coloring and the flour that was on the outside of our Skittle is dissolving still pretty quickly, but slower than the orange Skittle. So this would simulate a type of medicine, probably close to Advil or other pain relievers that you'd want to work quickly, but would not need to work as quickly as something like an EpiPen. So here we're just doing the same thing and flipping it over to make sure that that last little spot of purple is completely dissolved. So now that that's pretty much gone, I'm going to go ahead and take it out. And then here is our timer. So now I'm just pouring a new glass of Sprite into my clear cup so that I can see what I'm doing a little more clearly since my other Sprite was dyed orange and purple. So I chose to do my freestyle, which was where I have the really thick dough-like substance wrapped around my Skittle. So immediately you can see that the bubbles are a lot slower compared to the orange Skittle and the purple Skittle, although they are still kind of covering the whole coating. So I cut out some of the original footage that we had because this goes on for quite a few minutes and it's kind of boring just to watch because nothing really exciting is happening. But I did want to talk about how this would simulate a type of medicine that would need to be used for an extended release. So if you have an allergy medicine or different mental health medications, those are typically extended release drugs that need to work all day long. So as you can see here, this is obviously a very slow dissolving process, which is something that we would want to use for those types of medicines. So as you guys can see, we've really made no progress as far as any significant dissolving goes. It basically looks the same as whenever we first put it in the cup. So the whole point here was really just to show you that this would be something similar to how an extended release drug would work. And as you can see, it's been a little over 5 minutes, so I'm going to go ahead and take it out. And that is the end of our activity. Thank you guys so much for participating this week and watching our video. We really wish we could see you in person, but hope you're all staying safe. Bye!